Hi, I'm Janelle. I'm a fourth year animal science major doing undergrad research with Savannah. So I'm going to explain what distilled water is. Distilled water is basically purified water that has been run through a purifier. So we get rid of all the minerals. So we're just left with water, basically. And we're going to get 100 mils.
Mm-hmm. Explain how you're measuring it.
Okay, we're measuring based on concentrations for stock solutions we're making. And it varies based on the animal we're doing. So yeah, we're starting off with 100 and the level of mineral we're going to be putting will increase. So that will vary.
But you have a handy dandy sheet you can explain with.
We're going to wash these out first. So they don't have any, anything else in there.
Give them a little rinsey.
One contaminate the solution. Here we have our dilution sheet, and right here we have manganese sulfate and manganese chloride, the two forms of manganese we're going to be focusing on. Here we have our livestock that we will be evaluating, and right here we have the amount they're getting of the mineral, the NRC. Double that and then triple. And right here we can see that we have diluted by 10 milliliters. And based on this, we have made calculations for each level of solution we're going to be making. And right here we can see that this one was too... This one was too small to break down even further, so we had to add 100 mils of DI water. And this one could be breaking down further. So we added a bit more manganese and a little bit more water.
So are the concentrations the same even though you're breaking them down?
Yes.
Yes.
Based on the calculations and everything.
So again, what is this first level? Is half.
This is half.
That's level 2. Level 3 is what?
The NRC.
Level 4.
Triple that.
Level 5.
Wait.
Level 5. Okay, so double. Triple.
Double.
And then what is level 1?
Level 1 is just water, so we're not going to be adding any mineral.
So what does level 1 represent?
It's the control.
Control, yes. Very good to know.
Okay, and right here we can see for each level, so level 2, level 3, level 4, and level 5, we're going to be calculating how much water we have to put and how much stock solution we have to put. So level 1 is just going to get 30 mils of water because the control. Level 2 will be getting 25 mils of water and 5 mils of stock solution. While level 3 will be getting 10 mils of stock solution, 20 mils of water. Level 4, 20 mils of stock solution, 10 mils of water. And level 30 will just have 30 mils of stock solution with no water. Like I said before, we're doing manganese as our trace mineral for right now. And we are using manganese chloride and manganese sulfate. We're using these two specifically because they're most commonly used in feed. They're water soluble and they have higher bioavailability for livestock. So sulfate has 15 to 25% bioavailability and chloride has 2 times that. So we want to see how well the microbiome in these livestock, what's the word?
How it's affected.
How well they utilize it.
Yeah, perfect.
Labeling beakers of solution, just to not get them confused or anything, and based on the label so we know which one we're putting in. And we don't need a level 1 because it's just water. So it's going to be manganese chloride.
Why is labeling important?
So we don't get anything mixed up. And so everyone else in the lab can know what it is. So manganese chloride level 4. Last one, manganese chloride level 5. And that's it for labeling.
All right, now can you show us how to weigh out our?
Okay, we're
Chloride
going to be weighing out the manganese chloride.
Can you see the
And-
bottle?
And the calculations we made will be putting these amounts based off. So first, what we need to do for level 2, it's going to need 0.50528 grams. We're going to have to zeros scale first. Make sure we have the exact amount because we can't go over or under.
Which level are you currently weighing?
You're currently weighing out level 2, which is the smallest amount. So you got the amount.
Okay, so now that we got the amount, what's our next step?
Scale wants to be difficult. Okay. After we got the exact amount, we want to add it into the level we want. So we're gonna make sure to get all of it in.
Mm-hmm.
We don't want over or under. So this one's good to go.
Okay, so once we have that weighed and it's in, what's our next step?
We will be mixing it on the stir plate
Okay.
just to make sure all of it's dissolved.
Mm-hmm. With our Starburst.
Good to go.
Now, do we need to add heat to that or not?
It depends on the mineral.
And
Yeah.
for this one,
We don't need heat. We do need heat.
so just bump up the heat a little. Just a little. All right, and then we just let it what?
Let it stir for a bit. Make sure everything's dissolved.
Good.
Okay, so right here for sulfate, we can see based on the level how the color darkens based on the amount of mineral we're putting in each concentration. So obviously level 5 has the most, so it's going to be the darkest, while level 2 has the least manganese, so it's going to be the lightest.
Hello, my name is Sarah Hahn. I am Savannah's undergrad student, and I will be explaining what I am doing. So we are going to be using copper in 2 forms today. It's going to be used in the form of chloride and sulfate because they are the most available and dissolvable in water. So We have 5 different levels. The first level is going to be the control. Second is going to be half of the NRC requirement. Third is going to be the NRC requirement, double the NRC requirement for the 4th, and then triple the NRC requirement for the 5th. And so I will begin pipetting.
So why do we have A and B?
It's for replication, so that we make sure that it's not just a fluke. We see like consistent results.
Yes, good.
Okay, so for the control, we're going to put 30 water. So we use the pipette. And this is set at 0.5 or 5, so we'll pipette it in 6 times.
Shouldn't you be double tapping to make sure everything's expelled?
Since I did 6 of that, I'm gonna go ahead and close it to indicate this one's done.
Hi, I'm Satora Connie. I'm a senior at the University of Georgia studying biology on the pre-medicine track. Today I'll be showing you how to make media for our microbiome study.
Okay.
So for our ingredients for the rumen fluid media, it consists of salt A, salt B, cysteine, distilled water, and once we've put all the ingredients together, we'll be adjusting the pH to 6.5, and then we'll be putting it onto the
CO2.
We'll be putting it under the CO2, and we want our media to be anaerobic
Why?
because we do not want any oxygen in it.
Why?
Because we want it the oxygen would kill the media.
The media or the microbes in the media?
The microbes in the media.
Okay.
I'm pouring the distilled water into this flask, and then after we'll be getting the salt A and salt B. We will be getting 26.7 milliliters of salt A and salt B.
You have to give a little shake. Why is it hard to get out? Why is it hard to get out, Satora?
Because
The salt settles?
yes, there's too much.
There you go. You hop up there and get your salt bean.
And now I'll be getting 26.7 milliliters of salt.
perfect amount.
Yes.
Alright, now what's next?
Now we'll be measuring out the amount of cysteine, which is 0.4 grams.
And what is cysteine?
Cysteine is an amino acid.
Yes. Okay, so you can use the scale over here.
Okay.
So how much are we weighing out?
0.4 grams.
Go ahead.
Now we're going to do the gas, and I'm going to open the gas.
And what kind of gas is this again?
This gas is carbon dioxide.
Yes. Oh, before you put it in, always let it bubble to get any excess water out. You got it. So just turn the gas on high. See how it's going to expel the water? Clear the line. Of course, it may have been our media, but close enough. Alright, once it's clear, now we can go ahead and put it in. And then we're going to press down on the cap. And not too tight. Now we can adjust for the bubbling. So we only want a steady stream. So turn. Other way. So we just want a little bit of gas. One more. Towards me. Towards me. Towards me. Righty tighty. Because they only want a little gas. A little more. A little more.
More gas or less?
Less gas.
Okay.
Less gas. There we go. So, why do we want this gas?
So we want to take out all the oxygen out of the media so that it doesn't
Kill what?
kill the microbiomes.
The microbiomes?
No, the biomes. The biome.
The microbiome. So it's going to keep the microbes alive
Yes.
when we add what to it?
When we add the rumen fluid.
But are we doing rumen fluid?
No, not yet.
We're doing,
Media.
yes. And so we're adding what tomorrow?
So tomorrow we'll be adding the rumen fluid.
Are we taking rumen fluid or are we taking fecals?
We're taking pickles.
Good morning. So I'm gonna show you what we forgot to show you yesterday, which is how to take the pH of the media and pretend that we're going to take the pH and match the pH to 6.5. So the pH measuring device comes like this. We're gonna take it out of its little house and rinse it with some DI water and take a Kim wipe and then wipe it off. Then we put it into our media And while that stabilizes, I'm going to explain our acids and bases. So we have 2N-NaOH, which is sodium hydroxide, and 10% sodium hydroxide. So when we're using a larger volume of liquid, sometimes like a lower volume or lower concentration of sodium hydroxide will take a really long time because it is so dilute. So we can use a 10% solution, which is stronger, which will stabilize or get our media to a higher pH quicker. And then we also, if we were to go over 6.5, we have hydrochloric acid, which is acidic, so it would lower the pH. And we did that drop by drop, making sure that we didn't go over or under 6.5 because we want our media to be 6.5.
And it's at 6.5.
Yes.
Or at least it was yesterday.
Yeah, it was yesterday.
It's figuring it out. Nope, there it goes.
It's very finicky. So it's stabilizing. Hopefully it stays at 6.5. But
Now you see how it's done.
yes,
And now we can put it back.
we can put it back because it says 6.5 stable. We always want to make sure it says stable. And putting it back is kind of the same process as how we take it out. We want to rinse it with DI water. Take a Kim wipe, wipe that off. And then put it back in its house.
Okay, today
Not yet. Go.
Today we're going to be adding our distilled water with our sodium bicarbonate into our beaker, and then we're going to be stirring it. We have to make sure that the gas is in the beaker at all times.
Okay. Watch you pull out the gas. Then put it up there. So now what are we waiting on?
We're going to be waiting on our mixture to be properly mixed, and then we're going to be putting it into the media.
Yes. So how much do we need to add to the media? We're gonna cook.
We're going to extract.
Okay, go.
Hi! So today we're at the horse farm and we're coming over here to collect some fresh fecal. And if we can't find any on the grass, then we're gonna have to extract it from the horse.
This
Yes.
is our recipient. Hello.
And go.
Okay, hi, I'm Allison. I'm gonna show you guys how to rectally palpate a horse. So first thing I did was I went ahead and put my sleeve on. You wanna make sure that you don't have any jewelry on, anything that's gonna cause a rectal tear. I also went ahead and turned this inside out to make sure that the seams aren't going to be abrasive at all. So then next thing I'm gonna do is shoo this one horse out of the way. Go away, Nugget. And then I'm gonna come back here, move the tail to the side. I'm going to send my hands in like this pinched formation, like a triangle. And so what you want to do when you rectally palpate horses is go in gently. You don't want to force your way in. You kind of want to wait for them to, you know, open up a little bit more. Because if you go in too hard, they'll tear, and horses are kind of prone to that. So you just keep pushing in and pushing in. And you want to make sure that you're standing off to the side just in case the horse does kick. And then he's being a little bit tough, so you might just have to keep applying gentle pressure until they give up. Sometimes it becomes a little bit of a battle. And then you just want to grab some poop. And once you have it, you can make like a cupped shape with your hand and kind of pull back out. I'm not going to go in super far, but ta-da, you have poop.
Perfect. Okay.
You want to do it?
Yeah.
So, right now we're extracting the fluid out of the fecal, and we have got lovely Raven's poop. She just pooped right now.
Easier than the sheep.
Yes.
And go.
Okay, so we are going to weigh out 333 grams of our fecal fluid that we just obtained from the farm. So I'm going to put the beaker on the scale, and it's already at 0.00, but if it wasn't, I would have tared it. And now I'm going to open up
Our handy dandy lid.
our handy dandy lid. The trash can. And then I'm just going to pour until we hit 333.
It's pretty well strained.
It is because we actually strained it on the farm, and it was just direct fecal fluid, and instead of mixing the feces with our media like we normally do with the sheep. 333.62 actually.
That's good.
Okay.
So now we're gonna take it and add it. So if you will
Yes.
show us how to do that.
Yes. So we're gonna take our 333 milliliters,
Mm-hmm.
and we're gonna come over to our media that has been bubbling continuously. And I'm gonna push this down because it is important that it keeps bubbling to maintain the viability of the microbiota.
You might want to lift the lid just a little.
Awesome. I'm gonna have that on
Perfect.
the side, and then I'm just gonna pour this out.
Mm-hmm.
Oh my gosh, that's so full.
Mm-hmm. All right, now how long do we need to let it bubble for?
30 minutes.
And why is that?
So that the carbon dioxide really gets in our sample, and it will not activate, but like get the microbiota within the feces to really activate and get going.
Yeah, perfect. And explain what you're doing.
So the solution has been, our fecal and media solution has been bubbling for the past 30 minutes. So we will be pipetting the solution. I'll be pipetting 10 milliliters into each of the pipettes that also have gas running in them to make sure that the microbiota don't die while we're doing it.
And you mean tubes instead of pipettes, right?
Yes, I meant tubes.
And Janelle, what are you doing?
Okay, so while Sarah pipettes, I'm going to be moving this around each time she pipettes. So each time she puts the media in, we're going to make sure this carbon dioxide is coming in so it stays anaerobic because we don't want any oxygen to come in or it'll kill the microbes. And after we pipette and let the carbon dioxide run for a second, we're going to move it over and then we're going to cap it immediately so we keep that anaerobic environment.
Okay, and can you explain what Satara is going to be doing?
Okay, Sarah's not here right now, but
She went to get the Eppendorf tubes.
she will be capping the tubes with one of these little metal ones before we place them in the incubator.
Yeah, so she'll just use the crimper.
Yeah.
And she'll also invert the tube to make sure all the minerals are mixed in.
And then where do the tubes go when we're done with them?
Incubator.
Which is
Right over there.
right over there. And Janelle, you can adjust the gas as needed.
Our solution's not bubbling.
It's bubbling. Keep going. Invert, Satara. And then just put it on this rack over here by you. When that gets full with all the manganese, go ahead and put it in the incubator, Satara. what's an important part of this process? To make sure everything stays.
Seal tight.
Yes.
Recording.
Okay. Go.
Okay, so right here I'm recording the gas levels that are produced by each tube with the minerals, just so we can see the production of the microbiome.
Yep.
And in interacting with that mineral
Yes.
and the concentration.
Okay, so can you tell me what is Sarah doing right now?
Okay, so right now Sarah is injecting a little tube, and this is to check the gas. She'll inject the syringe and she'll let it rise for a bit until it stops. And that's all the gas that the microbiome is producing in there. So after that happens, I just record the number.
Okay, Sarah,
That's it.
what's the number?
It's still rising.
Still going?
Yeah.
What we got right now?
Right now we're at 0.9, and I think it's gonna stop there. Actually, 1.0.
Per tubing?
Yes.
Okay, and then you're going to inject the gas back.
Yes, and I inject the gas back, and then I'm gonna invert the tube to make sure everything is mixed up, and then I will draw around 2 milliliters. And then I'm going to put it into the correct Eppendorf tube.
Yep, and because we're taking our time measurements at what?
4 hours and 20 minutes.
Yep, and the initial at 0.
Initial at 0.
So you'll do this. Now, why are we skipping rows?
So once we have our samples in the Eppendorf tubes, we're gonna centrifuge them to spin it down to supernatant and pellet, so they separate. And the pellets are gonna be in one set of Eppendorf tubes. In this case, the I Eppendorf tubes, and then the supernatant is gonna be extracted and put into the J Eppendorf tubes.
Good.
Hi everyone! So I am putting our samples into the centrifuge to let the centrifuge separate our supernatants and our protein, and from there we will be putting our proteins into this row, which is where it's skipped. But our supernatants are to assess the volatile fatty acids.
And then what is the pellet used for to assess?
The pellet is used to assess
Protein.
proteins.
Protein. Yeah, you just said it. So essentially what we did is when you pipetted the samples in, this row is going to be left behind, so that will be your pellet. Versus the supernatant we pipetted into here, which you can use to extract the VFAs. And so we'll spin this for how long?
For 8 minutes.
On what speed?
On 20.
Okay. With the lid on there, right?
Yes, ma'am. Well, hold on, I was gonna do that. So we're gonna be taking the
Talk loud.
Sorry, we're gonna be taking the samples out of the centrifuge, and then later on we're gonna be pipetting the protein out and putting it into another set of tubes.
Okay.
Okay, I'm gonna let Janelle focus. So what is going on here is Janelle is gonna take each of the centrifuged Eppendorf tubes that have separated the pellets and the supernatant, and she's extracting the supernatant so that we have pellets for protein in one Eppendorf tube and volatile fatty acids from the supernatant in the other. And as she's done with the pellets, I'm just adding some sodium chloride in there.
What percent?
9%?
0.9%.
Sodium chloride. And then after this, we are going to vortex them so that they are all nice and homogeneous.
Okay. So why do we add the 0.9% sodium chloride?
I knew you were going to ask that question. And honestly, I don't know.
Anybody know?
Wait, what?
Yeah, why?
Wait, say it again.
Why do we add the sodium chloride?
So that it mixes with the supernatant?
No, because it goes in the pellet side.
I mean, sorry, because it mixes with the pellet, so that...
Okay, so
Why do we add the...
Yeah, do we just want it in liquid form or?
All right, so we add it to, if you add something to salt, what does it do? Is it going to stop growth, or would water stop growth?
Water would stop growth.
Salt would stop the growth. So we add, so we add the 0.9 sodium chloride so that it's going to what? Stop the growth in our,
Pellets.
which are,
Microbes.
no, which are our protein analysis. Uh-huh.
Okay, so what we're doing right now is we are mixing little centrifuge tubes with the pellet and the NaCl, and also just the supernatant tubes. Just make sure everything's mixed up before we put it in the freezer.
And so what are you using to mix these?
We are using the mini vortexer.
Yes, I'm glad you looked at the label.
So now we're going to be taking the gas levels from these tubes before we crack them open. Insert it. Okay, I think this one's dead because nothing is happening. So,
It's probably the control.
yep.
Okay.
Pop it out. Recap your syringe. We're gonna write what the level was. For this one, we didn't get anything.
So we're recording gas from 4 hour, 24 hour, and the pH at 24 hour.
Yeah. So now that we have the gas levels for 1B, we're going to crack it open. Take some DI water, clean off our little pH measure. We're going to stick this into the tube. And wait to get the pH measurement.
Takes it a minute to decide what it wants.
Yep. Okay. So after we get that, we just sit this down. We rate our pH level, and that was 6.85 for 1B. And then we go to our corresponding Eppendorf tube. So this will be 6K for 1B, and we're just going to pour some in. And this will be before, so we can centrifuge and get the supernatant and pellet. Just set that down.
Okay. Can you explain the labeling system on the back?
Okay, so what we have right here is we have, for every mineral, we have a certain labeling system depending on the form of whatever mineral we're using and the level. So let's say for CuSO4 copper sulfate. Oh, and also it depends on like the livestock that we're doing, so it'll be different. So let's say for copper sulfate level 1A, that will be 1I for the pellet and 1J for the 4 hour. And then for copper sulfate 24 hour, that'll be 1K for the pellet and 1L for the supernatant.
Right, because each mineral gets a certain number. For instance, copper gets 1 through 20, and the horses get what?
Is it I through L for the letter?
Versus swine would get A through D, but still copper would be 1 through 20. And then iron would be 21 through 40. And then manganese would be
4160.
4160. And then
zinc is 60, what is it?
61.
6180.
Yep.
Yes.
Hello. So today we're going to be putting in our Eppendorf tubes into the centrifuge, and what's going to happen is that the centrifuge is going to separate the supernatant from the protein, and then we're going to be extracting the supernatant from the Eppendorf tubes, and then we're going to be putting 0.9% of NaCl into the pellet to assess the proteins, and for the supernatant we're going to be assessing the volatile fatty acids.
Very good. So continue loading. So again, you want your centrifuge to be balanced when loading, which is why Satara skipped 2 spaces, because this can hold a total of 24 samples and we have 20 samples. Alright, so now that she's finished loading, she's going to put the lid on and then close. And now we adjust. So we want 8 minutes and
20.
start. And so at 8 minutes, our samples will be split and we'll be able to pipe out the supernatant.
Hello. So right now I'm extracting the supernatant from the pellet. As you
hold it
can
up?
see.
Oh, it's still really blurry. Stop it. Okay, so the bottom thing right there is the pellet, if you'll point to it. And then the rest of the liquid is the supernatant. So Satara is going to remove the supernatant and leave the pellet behind.
And then once I'm done extracting the supernatant from the pellet in the Eppendorf tubes, I'm going to be adding the NaCl into the tubes that contain the pellet.
And then once she's done with that, she's going to vortex everything so everything gets mixed in pretty well. And then it will be stored into the freezer until it is time for VFA and protein analysis. What are you doing, Satara?
So right now I'm putting 0.9% of NaCl into the Eppendorf tubes of the pellet. And what the NaCl does is that it stops the growth of the microbes.
Very good. And Janelle is happily pipetting away. And Janelle, what are you doing?
Well, I'm separating the supernatant from the pellet. So after I do that, the pellet's just going to be left, and that's when you can put the NaCl so it can stop the microbes from growing.
Perfect. Alright, what's the last thing we always do?
The last thing we do is wash all of our dishes so it's clean for our next experiment.
And then we will spray down and wipe our tables, right? And then once we get done vortexing, where do our pellets go and our supernatant?
They both go in the freezer.
And why?
So that we keep them in case anything happens to our samples.
Yeah, well, we're going to analyze our samples later, but right now we're not going to do that, so we're just going to keep them on ice until we're ready to analysis.
Yeah.